Hello student, today we are going to balance chemical reaction by oxidation number method, and there are some rules for balancing by oxidation number method, and today we are going to balance different chemical reactions. Here we have chemical reaction. We are going to balance this all chemical reaction, and these chemical reaction are of different types. There are some ions, and disproportion reaction also occurs here. So for this we have some rules to balance. Rules for balancing chemical reaction by oxidation number method. The first is to identify the atom which undergo oxidation and reduction. I already posted 2 videos on oxidation and reduction, in which a basic concept of oxidation and reduction, oxidizing agent, reducing agent, and calculation of oxidation and calculation of oxidation number. If you know the concept of oxidation and reduction, then we can go to the balancing chemical reaction and calculate the change in oxidation number per atom first and for total. First of all, we have to calculate per atom, and if there is a 2 atoms, if there is 3 atoms, then multiply by that atoms, total number of atoms. And after calculation of change in oxidation number, we have to crisscross oxidation number, oxidation and reduction. We have to crisscross multiplication for oxidation and reduction. And in 4, first balance which take part in oxidation and reduction. First balance that atom which take part in oxidation and reduction. For example, if nitrogen is oxidized, then first balance nitrogen. If copper is oxidized or reduced, then balance copper, and after that balance other elements. Balance metal and other. After balancing this atom, oxidation and reduction atom, then balance metal and other, and balance hydrogen. And if after balancing the hydrogen, oxygen is automatically balanced. You have to remember this. And at last, balance the charge or reactant. Balance the charge on reactant and product side by adding H plus, OH minus and H2O where is required. If there is a -2 charge in the reactant side, and if there is a 0 charge in product side, we have to balance, we have to make equal charge in both sides. So we have 2 options. We can make -2 in product side, and another is we have to make 0 charge in the reactant side. So if we need a positive charge, then we can use H plus and OH minus for negative, and water we have license to add water in either side. And there are some tricks which make you more comfortable to balance the chemical reaction. The first chemical reaction here, H2S plus SNO3 gives H2 plus NO plus S. We have to balance this by oxidation number method. So some important point we have to remember, which atoms is mostly go on oxidation or reduction. Or D block elements, transition elements. First of all, we have to see D block elements. They have variable oxidation number. So if there is presence of D block elements, we have to see that. And after that, carbon, nitrogen, phosphorus, sulfur, and halogen. In halogen, chlorine, bromine, iodine. These are frequently give the oxidation reduction, participate in the oxidation and reduction. So these are the atoms which frequently take part in the oxidation and reduction process. And let us balance this chemical reaction. First of all, write this chemical reaction. Here sulfur is in -2 oxidation number because hydrogen is +1, so -2 for sulfur. And in sulfur, in product side, sulfur is in 0 oxidation number, so this sulfur -2 to 0. minus 2 to 0 is oxidation, what, loss of electron. And we can also line here 0 plus 1 plus 2 minus 1 minus 2, if left to right increase in positive charge, oxidation, and here this is reduction. And next nitrogen here, nitrogen in HNO3, nitrogen in HNO3 is in +5 oxidation number, we can calculate. And oxygen here, nitrogen in NO, nitric oxide, oxygen in -2 and nitrogen is in +2 oxidation number. So change in oxidation number for nitrogen is change is 3, and it is process, it is reduction process. After finding out the oxidation and reduction, we have to write change in oxidation number. Change in oxidation number, change in oxidation number per atom of S equals to -2 to -0. Change how many? -2 to 0, 1 2, change is 2. And for nitrogen, change in oxidation number +5 to +2, +5 to +2 is difference is 3. Change in oxidation number per atom of nitrogen, change is 3. And here 2 and 3. So what is the trick? If there is 2 odd, multiply by 2. If there is 2 even, take common. And if there is 1 even and 1 odd, write as it is and crisscross. Now I am taking the chemical reaction here. Again, H2S plus HNO3 gives H2O plus NO plus S. Here the change in oxidation number sulfur is 2 and for nitrogen is 3. Now we have to crisscross. This 3 goes here in H2S and 2 in HNO3. Now write the chemical reaction here. I'm writing here. (3H2S) plus 2HNO3 gives H2O plus NO plus S. Now first balance that atoms which are in oxidation and reduction. So sulfur is oxidation and nitrogen reduction. So first of all we have to balance sulfur and nitrogen. So after crisscrossing, this one is fixed one, this one is fixed one, we do not change this. And for sulfur here you have to balance sulfur 3S, so you have to put here 3S. Yes. And for nitrogen, how many nitrogen in reactant side? 2. This is fixed, we do not change this, 2N, and we have to put here 2. This also fixed and this also fixed. Remaining is water. So water, we have to balance water here. For that, hydrogen and oxygen, we have to balance now hydrogen and oxygen. Remaining part is hydrogen and oxygen. Total hydrogen is 3 2 is 6 plus 2 8. So there is no hydrogen, there is no hydrogen, we have to put here 4. 4 2 is 8. So total hydrogen is 8. Now hydrogen is also balanced. After balancing hydrogen, oxygen is automatically balanced. If not, then you are wrong. So calculate oxygen here in reactant side, 3 2 is 6, and in product side this is 4 and 2. So balance, this chemical reaction is balanced. This one is very simple. So let us see another chemical reaction. Next chemical reaction, Zn plus HNO3 gives ZnNO3 whole 2 plus NH4NO3 plus H2. This is little different type. This is different type of chemical reaction. So there is some trick and some concept too. So watch carefully. Here let us calculate the oxidation number for zinc. For zinc in elementary form it is in oxidation number 0. And in this side, zinc nitrate, zinc has in +2 oxidation number. This is in +2 oxidation number. This is +2. Okay, sorry. And in HNO3, nitrogen in +5 oxidation number. Here there is nitrogen in zinc nitrate and nitrogen, 2 nitrogen in ammonium nitrate. So which nitrogen has in different oxidation number than this? Or we can say that zinc is here oxidized, 0 to +2. Zinc is oxidized. So we have to see that nitrogen which is reduced. Zinc is oxidized here, oxidation. And we have to see nitrogen here in ammonium nitrate. Here is 2 nitrogen. One nitrogen bonded with this hydrogen. In nitrogen and hydrogen, we already calculated the oxidation number of this nitrogen before. Here this nitrogen is in minus oxidation number because it is bonded with hydrogen. Hydrogen is electropositive, and this nitrogen in plus. So we have to see here plus. If we calculate the oxidation of this nitrogen by putting NH4 plus, calculate oxidation number for NH4 is +1, then we can calculate +5 oxidation for this nitrogen. If we put NO3 minus the radical, oxidation number -1, then we can find the oxidation number for nitrogen is -3. So we have to take this nitrogen for reduction, +5 to -3. Decrease in positive charge is reduction, gain of electron. So this is reduction. This is what? Reduction. For zinc, change in oxidation number for Zn equals to 0 to 2, that is 2. And change in oxidation number for nitrogen, +5 to -3. +5 to 0, 5, and 3 -3 means total change in oxidation number for nitrogen is 8. So we have to take common because both are even. So take common. By taking common 2, 1 and 4. Now crisscross 4 for nitrogen, and 1 for zinc. 1 for zinc and 4 for nitrogen. After crisscross, here we are crisscross. Here zinc has oxidation number change 1, and for HNO3 there is 4. Now crisscross this. After crisscross, we'll get here 4 Zn. I'm writing here 4 Zn plus HNO3, 1 HNO3 plus. I'm leaving here some space because I have some trick here. Zn NO3 whole 2 plus NS4 NO3 plus H2O. This is already balanced, so we do not change this again. Here now zinc is 4, so we can write 4 here. This balance, this is fixed. This one is fixed, so do not change this again. And nitrogen is reduced here, but in the product side there is nitrogen in zinc nitrate. So to balance this nitrogen, we have to put another HNO3 here. So this is the trick. What is trick? If there is a 2 or more than 2 nitrogen presence, or 2 or more than atoms are present which is oxidized or reduced, then at that reactant how many times that presence in the product. It means here this nitrogen balance this nitrogen only. To balance this nitrogen and this nitrogen, we are adding this HNO3 here. Now this balance after zinc and nitrogen, we have to balance here this nitrogen. Now this nitrogen is 4 to 8, 4 to the 8, and here is one nitrogen, so total nitrogen is 9. So this is also balanced. This nitrogen is also balanced. Zinc, nitrogen, and this nitrogen totally balanced. So we do not change this also. After balancing this, we have to balance hydrogen and oxygen. In reactant side, all the reactant are balanced, so total hydrogen is 10. In product side, there is a 4 hydrogen, so we have to take here 3 2 equals 3 to the 6, 6 plus 4 10. If the oxygen is automatically balanced, then your chemical reaction is balanced. If not, there is some wrong. Let us see. Here oxygen is 9 3 is 27 plus 3 30 oxygen, and in product side there is 4 3 3 2 is 6, 4 is 24. Here is 3 oxygen and here is 3 oxygen, so total 30. So we balance this chemical reaction, and again you have to write to add this total nitric acid. Let us see another example. It's very important example. In this chemical reaction, there is a D block elements chromium, so you have to calculate the oxidation number of chromium here. Here chromium is in +6 oxidation number. You can calculate it by oxidation. And here is Cl in -3 and +3 oxidation number Cl. So change in oxidation number for Cr, I'm writing here change in oxidation number 6 to 3 is 3. Change is 3, and this is what +6 to +3 is reduction. This is what reduction, and change equals to 3. And for another, here hydrogen do not change, potassium alkali metal they do not oxidize and reduce, and in HCl there is a Cl in -1 oxidation number. We can see here Cl in 0 oxidation number state, elementary form. So for this Cl, we see there -1 to 0, change equals to 1, and this is what -1 to 0 loss of electron. This is oxidation. So before crisscrossing 1 and 3, we have to remember that these both are odd or even, or we are calculating the oxidation change in oxidation number per atom or total atom. In above two questions we do not discuss about the total atoms, but here is Cr2. So per atom change is 3, and for Cr2 for 2 atoms it should multiply by 2. Total change in oxidation number for Cr equals to 3 into 2, because Cr is 2 Cr2 form, so 3 to the 6 here. And change, and for Cl here -1 oxidation number, and here is 0 for Cl equals to change is 1 and 6. Okay, now crisscross K2 Cr2 O7 plus HCl, and here this Cl balance this Cl only. This Cl do not balance this. If after crisscross if we change this HCl, then there will be the mode heat and trial method. So we have to take some trick here. We already discussed about it. How many Cl in product side? In here is Cl, in product side there is one Cl, another Cl molecules, and this Cl2 is balanced by this Cl, but for to balance this KCl and CrCl3, this Cl, we have to add another HCl2 HCl here and write the product KCl plus CrCl3 plus H2O plus Cl2. This HCl balance this. You can assume that this HCl balance this, and that which is in oxidation HCl is this one, and this balance this. Okay, now crisscross. After crisscrossing, here Cl in 1, so 1 is in front of K2Cr27 and 6 in this HCl, 6 HCl here. Now balance that atoms which are oxidized or reduced. Here first balance Cr and then Cl. Cr in reactant side total 2, here 1, so we are putting here 2. Now balance this Cl. In this already balanced, do not change this number. And here is how many Cl? 6 Cl, and this HCl balance this Cl2, so we have to write here 3 Cl2. After this, balance potassium because it is metal. After balancing this change in oxidation atoms, balance metals first. How many potassium here? 2, so we have to put here 2. This is balance, this is balance, and this is balance. Now, and for HCl, here this HCl balance this KCl. So here how many Cl? Oh, in product side there is 2 KCl, there is 2 Cl, so we have to add here 2. This also balance. After balancing this HCl, now turn for this Cl. How many? This is already balanced, so how many Cl here? 3 to the 6, so we have to put here 6. Now in product side there is only water. All are balanced except hydrogen and oxygen. First balance hydrogen here. How many hydrogen here? 6, and 6 plus 2 8 plus 6 14 hydrogen here in reactant side, and there is no hydrogen, there is no hydrogen, there is no hydrogen. Add here, multiply by 7 to the 14. If oxygen is balanced automatically, then your chemical reaction is balanced. If not, then wrong. So let us see here. Oxygen, total oxygen 7, here 7, so this chemical reaction is balanced. And write this chemical reaction again here, K2 Cr2O7, and add this HCl, total HCl 6 plus 2 8 16 14 HCl, 2 KCl plus 2 CrCl3 plus 7 H2O plus 3 Cl2. Let us see another example. KOH plus Br2 gives KBr plus KBrO3 plus water. In this case, potassium, oxygen, hydrogen do not oxidize, reduce here. Br2 only oxidize and reduce. So this Br2 is oxidized, this Br2 is reduced. So one element is oxidized and reduced. This means this redox reaction is a type of disproportion reaction. Let us see the oxidation number. In Br2 it is eliminated form, so oxidation number of Br2 is 0. In KBr, Br is in -1, potassium +1, Br -1. In KBrO3 you can calculate the oxidation number of Br is +5. Now this Br 0 to -1, 0 to -1 is reduction, and change is 1, 0 to 1. And for this Br, oxidation, loss of electron 0 to +5, oxidation, and change is 5, 1 and 5. But Br2 in reactant side, here Br2 in reactant side. So we are writing this equation again here, KOH plus, we are writing here in two part, Br2 is oxidized and Br2 in reduced. So Br2 I am writing here 2 because it easy to balance this chemical reaction. Br2 because one Br2 oxidized, another is reduced. So KBr plus KBr3 plus H2O. Now here change in oxidation number per atom of Br is 1 and for another is 5, but here Br2 is present, so we have to multiply this 1 by 2. 1 into 2 equals to 2, and this multiply 5 into 2 equals to 10. Why we are multiplying? Because there is a total number of atom is 2. For this Br2 multiply by 2, we calculate for per atom is 1 and for total 2 multiply by 2, same as for the Br2 and KBr3. So total change in oxidation number is equals to 2 and here is 10. 2 and 10. And 2 for this Br2 and 10 for this Br2. Both are even and there is common. So we are taking common. After taking common, we can write here this is 1 and this for 5. 1 and 5. Now crisscross this chemical reaction, crisscross this oxidation and reduction. After crisscrossing, we will get KOH plus 5 Br2 here plus here 1 Br2, only Br2, KBr plus KBrO3 plus H2O. It is easy for this chemical reaction. If we write Br2 once time, we can also balance, but there are some complicated chemical reaction, and if we use only only one element, then it will get more complicated. Now let us balance this chemical reaction. First we have to balance that element which oxidize and reduce. First of all, we have to balance which is crisscross, this 1 and this 5. So Br2 here, Kb, this Br reduced to this Br, so I am taking like this, and this Br2 oxidize to this KBrO3. So to balance this KBr, here is 5 Br2, total 10, we have to take here 10, and for this Br2 here is total 2 and we have to put here 2. This balance, this balance, this balance, this balance, we do not change this. And now balance potassium here. For potassium, total potassium K in product side is 10 plus 2, 12. This already balance, so 12 K we have to put here 12. This also balance. We only multiply molecules once time. 12 K potassium also balance. Now remaining hydrogen and oxygen. So first of all, balance in 99% case we have to balance hydrogen first, and oxygen is automatically balanced. So here 12H, and here is no hydrogen, here is no hydrogen, so we have to put here 6 to the 12. And if there is oxygen already balanced, then chemical reaction is perfect or balanced. Let us see, 12O, and here is 3 to the 6 plus 6 12. Now write this chemical reaction again and add this 5 plus 1 6, 12 KOH plus 6 Br2 gives 10 KBr plus 2 KBrO3 6 H2. In this chemical reaction we can take common 2, then also write chemical reaction. If there is common, then we can take common 6 KOH plus 3 Br2 and 5 KBr plus KBrO3 plus 6 3 S2. We are taking 2 from this 6, 2 from this 3, 2 from 5, 1 and 3. Now let us see another chemical reaction. Cr2O7 minus minus plus C2H5OH gives Cr plus 3 plus CO2. This is in ionic form, so we are going to balance by this oxidation number method. In this chemical reaction, chromium is in plus 6 oxidation number here, and here is plus 3. So for chromium, change in oxidation number, change equals to 6 to 3 plus 2 plus 6 to plus 3 is 6 minus 3 is 3. Plus 6 to plus 3 is reduction. And in C2H5OH, let us see, carbon has oxidation number. Let us calculate. Plus 5, hydrogen is plus 1 plus 5, and this is minus 1 OH minus, plus 5 minus 1, we'll get plus 4. In product side, minus 4 divided by 2 minus 2. And CO2 in oxygen in minus 2 into 2 4 minus 4, it means carbon in plus 4. So carbon is oxidized, and change for carbon is change in oxidation number for carbon is minus 2 to plus 4, means minus 2 to 0 is 2 and plus 4 means total 6. Change is 6. Change equals to 6. Now here change equals to 3 for chromium. It is for per atom of chromium. So there is 2 atom of chromium, so we have to multiply by 2. 3 2 is 6. And here is also carbon. Carbon has 2 atom, so we have to multiply by 2. So 6 2 is 12. First of all, we have to calculate the total change in oxidation number. Here we calculate 3 oxidation number for per atom, and here is 2 atom of chromium, so multiply by 2. After multiplying, if there is common, then you can take this common. Now here we are writing again chemical reaction. Cr2O7 minus minus plus C2H5OH give Cr plus 3 plus CO2. For chromium, the change in oxidation number for chromium is 6, for carbon is 12. We can take common here 6 and we'll get 1 and 2. So multiply 2 in Cr2O7 and multiply 1 here. 6 and 12, but we are taking 6 common. If there is a common, then we have to take that common. So again we are writing chemical reaction here. This 2 multiply to Cr2O7 minus minus plus 6 C2H5OH, and I'm leaving some space here to add here, plus 3 and CO2. Now balance. This is balance, this is balance. You do not change the number. So there is no 6, there is 1, sorry, 1. This is already balance. Now how many chromium here? 4, so you have to put here 4. This is balance. How many carbon here? 2, so you have to put here 2. This is balance. All are balanced, but there is no balance of charge, so we have to balance this charge. To balance the charge, we have to see here how many charge in reactant side. Minus 2, total minus 2. In product side, there is total plus 2. If acidic medium, we have to add H plus in reactant side. If basic medium, we have to add OH minus in reactant side. Yes. So here minus 2 to plus 12. Here we have to going to add H plus here in product side, that is in acidic medium. So we are adding here H plus. We already discussed about rules of the oxidation number method. And here now how many charge here in product side? Total plus 2. So we have to make plus 12 -2 to +12. No, there is no -2, there is -4. There is -4, 2 to the -4. So -4, add how many proton here? We have to add 16 proton here, so we'll get +12. So we have to add here 16 H plus. Now this fine, this is balance. In product side we have to add water, because hydrogen is added in reactant side, so we have to add water in. We have to add water in either side. We have license to add water. And let us see, let us balance hydrogen. In reactant side, how many hydrogens? 16, 17 and 5, 22. So multiply by 11, 11 to the 22. Hydrogen is balanced. Now if oxygen is balanced, then our chemical reaction is balanced and right. Let us see how many oxygen in reactant side. 7 to the 14 and 1, this one 15, 15 oxygen. And in product side, how many oxygen here? In water 11, and here is 4, 15. So this chemical reaction is balanced.